Yes, and it's nice to hear from you, Patrick. It's Izzy's just messaged me to say that she's struggling a bit with the speaker, so no problem. I will record this anyway, and it's going to be very brief anyway. James, I hope you pick it up and watch the recording, or join us in a few minutes. Either way is fine. So let's just get the shared screen. So you will remember that the last bit you did was doing some SUVAT equation work where you were using V equals U plus AT and S equals U plus V over 2 times T. And again, just to remind you, from the velocity time graph, you can get the first equation from the gradient, and from the area under the graph, the trapezium, you can get this equation. So those two, as you know, you need to be able to derive those from first principles. Now, the other 3 or 4 are all come from just the algebraic process of manipulating these two. So they are set out on this slide. So in short, you need to be able to use and to derive the 5 formulae. So just so you're clear, the first 2 are the ones that you are deriving from first principles, and then just with the algebra, you would then can get the other 3. So it might just be worth just working through that algebra. It's not difficult, just to prove you can do it. The formulae are given at A level, so they are in the formula booklet. So you don't actually need to remember them as such. You know, if you have a blank and you forget one of them, I think particularly that bottom one, because we don't use that one very often. Certainly in my day when I did physics a long time ago, we didn't even use that one. But certain, so they are given, but in theory, in the A level, they could ask you to derive the first 2 from first principles, and then secondly to go do the algebraic process to then move on to numbers 3, 4, and 5. So they're the 5. Now, the next exercise is just going to be using the latter 3. I think examples 7 and 8 are self-explanatory. I would just read through those, please. I do think there are a couple of points in example 9 that are just worth just bringing to your attention now, please. So obviously, draw a sketch is always a sensible thing to do. Now, when we have a situation where we are decelerating, okay, just think it through. Say we're moving from left to right and we're decelerating. So we're getting slower and slower and slower and slower and slower until we actually come to a stop. But then as you continue decelerating, your direction changes and you start going back to where you started and beyond. Okay, so if you are asked, so a typical question when you're decelerating, to find the time between the instant when P first passes the origin and when it returns to 0. Remember, obviously, your deceleration will be a negative acceleration. The question tells you your opening speed, U is 2.5. But the big point, remember, when you get back to 0, your S equals 0. It's your displacement. It's not the distance traveled. Obviously, the distance traveled would be there and back again. Okay, that's what we cover in part B. Okay, but it's so just remember, S is displacement. That is how far away you are from your starting point. So clearly, when you begin, your S equals 0, but your S is also 0 when you get back to where you started. So S equals 0 to answer part A here. Okay, now for part B, to work out the total distance traveled, okay, what you go and do, you start off by just work out how long it takes to go from O to A. And then because the whole thing is symmetrical, you can just double that time. It will be the same time to go back from A to O. So for part B, you'll see that you've worked out that the displacement, the distance from O to A, sorry, the distance is 45 meters. So doubling it, that's where you get your 90 meters. Now, to work out the first bit, okay, to work out the distance from O to A, obviously we know the deceleration, we're given it. We know the opening speed, but remember, at that point when you just turn around from going left to right to left, for an instant, your velocity equals 0. Okay, so for part B, that's the key bit to take on board. So displacement equals 0 as you return to the origin. Your velocity equals 0 as you change direction for that split second. So that takes you into exercise 9D, and I would like you to work through that. Now, we only have one lesson the week after half term, okay? And you won't know this yet, but there's going to be a letter going home to your parents today where we're sort of canvassing opinion on how things are going with lower sixth. And we are required, each of your teachers, so that would be all three of Mrs. Miskin, Miss Cummins and I, will need to have a 10-minute chat with you sometime during that first week back. Now, I only see you that one occasion. I forget, it's either the Tuesday or the Wednesday. It's the Tuesday. So we are going to need to have our 3 10-minute chats during that lesson. I've got no choice. It's the only time I see you that week, and it has to be done that lesson. So really, the long and the short of it, this exercise 9D, I want you to get done now, please. And on Tuesday's lesson, when we are back, with the exception that 10 minutes, we'll just be having a quick chat just to see how everything's going. Okay, so I think that was everything I wanted to cover. I'm assuming, as always, if you're getting stuck on anything, please do let me know. Any question you don't understand, let me know, and I can just do a little video explaining it. I think I've gone and given you the PDFs of all these answers already. Perhaps one of you could drop me a note if you don't think I have. I certainly meant to have attached that to show my homework earlier on when we started this chapter. So I think I've done that, but I stand to be corrected. So if one of you tell me otherwise, I have. Yeah. I have. Thank you, Izzy. So I have done that. So, I mean, I'm not saying my slides are great. There's probably not much more detail there than when you just looked at the work solutions, but sometimes I include an extra step that the book doesn't. And certainly mine are more colourful. I use my fluorescent pen and stuff. So that's it, guys. Do try and have a rest over half term. I mean, it's school policy, but I also think it's wise. Just give yourself a proper week's break, even if you've got a bit behind. I would just give yourself the week off. Okay, guys, nice to see Patrick and Izzy. We'll hear from Izzy. Nice to see you, Patrick. I don't know if James joined us. Are you there, James?
I am here.
You are there, James. Nice to hear from you too. Thanks for joining us. So in short, you by the end of the first week back, to be up to date, you will have done 9A, 9B, 9C, 9D. So you've got a bit of time. Okay, cheers, guys. I hope you have a super half term. Bye.
Thank you.
Bye.
Thank you.
Cheers, Patrick.